The first problem that I have up here is the first problem from the worksheet at the bottom of the worksheet. And that problem said x is greater than or equal to 0, y is greater than or equal to 0, which are my little red lines here that you can kind of see. So really creating a barrier, making the graph, forcing the graph to be in the first quadrant. That's a restriction or a constraint. So now all of my values for x and y must be positive. The third inequality was x plus y is less than or equal to 8, which is really y is less than or equal to negative x plus 8. And then the last one becomes y is less than or equal to negative 2/3 x plus 7. So when you graph them, you have the vertical and the horizontal line, and then the two other lines with y-intercepts that are just one off from each other, so it makes a larger shape because the y-intercepts are just one greater than the other. This is a quadrilateral. After you graphed it and you shaded in the feasible region, which all of those solutions or answers in there would be your solutions, but it specifically asked you to list the vertices, and the vertice would be the two lines meeting to form a point that creates like a boundary for your graph besides just the lines. So those points would have been 0, 0, 8, 0, 0, 7, and 3, 5.
Is there a triangle out?
It is not a triangle because this line has a different steepness than that line does.
Nice.
So it's two different lines. It does create a quadrilateral. Slightly
Oh,
off.
I just shaded the wrong part.
I did that at first too, Cooper, and then
I was
called my mistake. Did you shade that little tiny triangle?
Okay.
I did that at first.
So
Caught that mistake.
lastly on both of those lines, yeah, it gives that little shape there. All right, so the second one used A and B, and if you don't like A and B, write them as X and Y. So that's totally your call, but if you don't have to have A and B. Or you could label your graph, like you could label the x-axis as A and the y-axis as B. That might help when you're graphing them if you're keeping them in the terms of A and B. The first one said A is greater than or equal to 0, or x is greater than or equal to 0. The second one, we talked about this compound inequality yesterday, how to split it up into its two separate. So starting with the B, reading to the left, B is greater than or equal to 2, and then going right, B is less than or equal to 6. So that really, these two inequalities, or they're the y variable. So that's why I have horizontal lines for those, because I'm going up to 2 on the b axis, up to 6 on the b axis. And then the last one here, it's 2a is less than or equal to b. I like my y to be on the left side, so I literally just flipped it. So I put the b on the left. The greater than sign was facing the b, it's still opening towards the b. So these equations or inequalities are the same. I just flipped them so that the y variable or the b variable was on the left side. So this has a y-intercept of 0, starts at the origin, and it has a slope of up 2 over 1. That is not a horizontal line. So it does have a slope of 2. So again, you get a quadrilateral here. This one is a trapezoid because it has two pairs of parallel lines. And then your ordered pairs, the vertices 0, 2, 0, 6, 1, 2, and 3, 6. Are there questions on those two problems?
Wait, is someone for that?
No. Me.
Oh yeah.
Yeah. Hey, me. All right, so number 3 had a value, or the u and the v. So u is really x because it's first in the alphabet. So you got to say your alphabet, remind yourself which comes first and second. V is the y because it's after the u in the alphabet. And when you're graphing this, so yours might look a little different because what I did, I noticed that the x was going up to 15. So I decided to move my y-axis to the left. So instead of using this line as my y-axis, I moved it left. And I moved it left 6 so that I could use that line to be 6. If you chose to extend your graph, you could extend your graph, you could count by 2s. So if you counted by 2s, your graph should look the same, it's just smaller than mine. And I chose not to count by 2s just so that I had a larger graph to show. So your graph should just be like, oh, smaller than what mine is. But again, u is greater than or equal to 6, or x is greater than or equal to 6. U is less than or equal to 15. So if you counted by 2's, your graph just is squished. It's going to be more narrow than mine. And then solving that third inequality there, negative 2/3 x plus 12.
I did them. I don't know why I did them in that order. I once started in that order.
So does anyone have questions on those 3 problems?
No. I have a question on number 4.
Okay. All right, so then let's look at the 4th problem. This one was tiny. No matter what, there wasn't any way to, I guess if you wanted to make every 2 blocks represent 1. And getting the points was a little harder in this graph.
Yeah, that's what I was
Yeah. So when you graph this, you're graphing negative 2x plus 6, and then you're graphing negative 1/3 x plus 8/3. Because of that 8/3 being a fraction or a decimal, when you find the lines that intersect, this point here is in between 1 and 2. And then this point here is going to be in between 2 and 3 on my x-axis. So to get to those values, we kind of talked a little bit about this yesterday. I have here that at this point, x is equal to 1. I know x is 1 because that's where my vertical line, my x equals line is. So this line is x equals 1. That means the 1 value for the x has to be part of the ordered pair. We don't know what the y is, though, because it's in between 2 and 3. But if I know the x is 1, I can take that 1 and plug it into the equation. The equation has the 8/3 as the y-intercept. So right here is the equation. So y, I'm going to just make it equals because now I'm actually trying to find the y value. So negative 1/3, and then my x is 1 for that ordered pair. We just need to find y, and then plus 8/3. So if we have 8/3 minus 1/3,
7/3.
it's 7/3.
Wait, what's the first one that you wrote? It's like 2, 5, 1. What is that?
2.5.
Oh, 2.5 again.
Yeah. This is a decimal. 2.5, 5 halves. I don't know why I wrote that one as a decimal and the other one as a fraction. Beats the heck out of me. So to get that other value then, so this point right here is the other one that's in between 2 boxes. That's on the line y is equal to 1. So in your problem, if y is equal to 1, here's that line that connects, and that line has the y-intercept of 6. So my y value is now 1 because it's crossing the y equals 1 line, and then the equation is negative 2x plus 6. So if I take the 6 to the other side, I end up with negative 5, and then when I divide, you get 5 halves, or 2.5. So you're taking one of the values that you know. So we knew y had to be 1 because that's where the horizontal line crossed through the point. But we didn't know the x. So if you know one of the values, you can plug it into the equation to get the other one. You have to plug it into the right equation, though, because there's 2 lines that are going diagonally there. So it's picking the right diagonal line in its equation that it matches with. Any questions with that? So that would be like the tricky part here is if it's not connecting exactly, knowing what to plug in to the equation to get that ordered pair. So this point here is 1, 1. That one's easy. And then this one does cross exactly at 2, 2. So it's the 2 that were in the middle there. Questions? All right, so the other graph that I want to show you then is from the book. And that was number 4 in the book. Number 4 from the book, you are asked to graph it and then find the maximum and the minimum value. To do that, you need to have the graph and the ordered pairs, or those vertices. You take those ordered pairs to plug them into the function that they give you, and that's the objective function. We'll talk about more of that today. So 0, 0 is obviously the minimum because you plug 0 into anything, it's still going to be 0. And then the 5, 0, and then 0, 5. 0, 5 was the max value because it was being multiplied by 4. So the maximum was 20 based off of the objective function, and that occurred at 0, 5. So if I did a different objective function based off of that function, I could have different max and min values for the same graph. So this is just based off of the given function. Questions? Are there other questions with the homework that I didn't cover? So make sure that you keep keeping your homework in a safe place, knowing that the notebook quiz has homework on it. I'm not collecting it today. But you could be asked a question with number 4 saying, what is the maximum value in the problem number 4? Of course.
Thank you.
You're welcome. All right, so in your notes packet, I would like you to turn to page 19. Page 19 has the last section or portion of section 3.3 dealing with these inequalities. And it involves word problems. So now taking what we did yesterday, trying to apply it to something that we can actually think about, something object that we can try and work with instead of just saying, oh, this is a graph, it doesn't really mean anything. So 2 vocab terms, the objective function we kind of talked about yesterday. Objective means goal, so that would be like our goal to get for the problem, but it's also gives us the maximum or minimum value of the function or of the graph. So I'm going to say it gives the maximum or minimum value of the goal or for the goal, but objective is something we're trying to meet or match. Underneath that is the corner point principle. The corner point principle talks about the vertices from your feasible region. Remember, the feasible region is just that shaded object shape that you have. So vertices from the feasible region. Can be used to find or calculate the max and min. So the maximum minimum value of the objective function will only come from the corner points. If it's inside your feasible region, so if this was my feasible region, if it's somewhere inside of it, then it's going to give me a number that's in the middle. If it's somewhere on the outside of the corner, then it would give me either a max or a min. The max or min will never come from the middle, because if it's in the middle of the graph, it's not going to be a middle value of your function. Questions? So if you look at the first problem, you have 2 problems like this for homework, which to me seems pretty fair. So we're going to go through 2 problems in class, and then you've got 2 to do for homework. In this one here, we are a small company that makes animals for a toy store. And they decide that they're making lions and giraffes. Who doesn't love lions and giraffes? Might as well make some stuffed toys. The toy store, you don't like lions or giraffes? Both?
No, just like cute
Oh, I was
lions.
gonna
Like
say,
cute
the
stuffed
giraffes
lions,
scary?
lions. Lions kill.
Well,
So do you.
It's part of nature. and
that's
circle
that's
of life,
quite a
so-
good response, Isabella.
I hope they kill you then.
So our company decides to make no more than 75 animals in all. And they want to keep the number of giraffes to no more than 5 more than the number of lions, which that part there is very wordy. So the number of giraffes are supposed to kept to be no more than 5 more than the number of lions.
Should there be more than one?
Alright, so let's see if we can try and come up with constraints. Remember, constraints are the inequalities that create our system. Nina, what do you think?
Okay, x plus y is less than or equal to 75.
Nice.
So by now you should know that that type of inequality is probably going to be used in most of the problems that we deal with. The two types of animals, no more than 75, which is why it's less than or equal to. If the variables weren't defined for us like they are here, make sure that you are defining the variables. So you have to decide when you want your x and your y, or your L and g if you want to use L and G. Alright, so that's one of them. If you pass the word and, we have to try and make sense of to keep the number of giraffes to no more than 5 more than the number of lions. Dylan?
Y is less than or equal to x plus 5.
So he said y is less than or equal to x plus 5. So if we just look at the 5 more than the number of lions, the lion would be x. 5 more than means x plus 5. Giraffes are no more than, less than or equal to, 5 plus the number of lions. So that's what this inequality is actually stating. So giraffes is y, no more than, less than or equal to, 5, or the number of lions increased by 5. Any others?
I feel like there is value
Yeah,
Okay.
I don't think there's no.
there is.
Well, x has to be greater than 0 and so is y.
Yeah.
Probably.
It's allowed to equal 0 because we could choose not to make one or the other. So we wouldn't have to make giraffes, or we
Actually,
wouldn't have to make
What if,
lions.
no, if they made
You can't make
lions,
zero
then they would
giraffes.
have to have giraffes. No, if they made,
Yeah.
yeah,
But doesn't yeah.
Yeah, you can't.
Why?
Because you have to be 5 more.
You can't make zero giraffes.
because if you're gonna make 75 animals and
Yeah.
a giraffe has to be 5 less than lions, then you can't make no lions, because if you make no lions, then you have to make negative 5 giraffes.
So when, yeah.
So then
So
there would
if
be
you
negative 5 animals made instead of 75 animals made.
Oh, proud of you.
That's pretty good.
Okay, Ethan.
So keep the number of giraffes to no more than 5
Yeah,
more
so
than the
why
number
is-
of lions.
Y is be greater than equal to.
5.
Yeah.
So the highest.
Alright, so we'll change this to just greater than.
Would it be fine?
Ooh.
Really
Okay, so it wants us to graph the feasible region and find the coordinates of the vertices. So if we're finding the coordinates of the vertices, essentially you want to find the two places where the lines will connect or meet. When you look at the graph, because it's x and y is greater than or equal or greater than 0, you can make the edge of the graph your x and y axis. So you don't need to put it in the middle of the graph. And then we'll graph those two lines.
Are we gonna count by 5s?
We are going to count by 5s.
Are we really?
So because we have to go up to 75, there are only 20 lines on there. Counting by 5s works pretty nicely, especially because I have 5s in my problem, numbers divisible by 5. So really, this equation that we're graphing is y is less than or equal to negative x plus 75. And the other thing, make sure you're labeling your graph. It's now a word problem, so it represents something. The x-axis represents the number of lions, because that's what x is talking about. The y-axis represents the number of giraffes. And no, you don't have to label every single line. Label a couple of them. So if you're counting by 5s, that's fine.
If you want to.
But a couple being labeled is enough. as long as I can see what you're counting back.
It's cute.
So negative x plus 75, go all the way up to 75 on your graph.
Come on, get on my day.
And then the final inequality would be x is less than or equal to 5. So that starts at 5 less than or equal to. And the slope is a positive x or a positive 1. So it kind of looks like a triangle, but it isn't quite a triangle because of that left side of the graph there, making it a vertical little portion of the graph. Make sure you shade it in. Our feasible region needs to be defined, so shade in that feasible region.
Yeah.
And because they're less than or equal to, it's the portion underneath those lines. So if you're not sure where your graph should be shaded, look at your inequality symbols before you start shading.
Crazy. Shade that boy in.
And then if you list the corner points. So 0, 0 is technically a quarter point, but we know that that isn't going to be an option. Cooper, what are the other order pairs?
0, 5, 75, 0, 35,
35.
I don't know, how many 40.
40.
Cupert's amazing.
So, knowing that we need to make 5 more giraffes than we do lions, that leaves us with either having 0, 5 or the 35, 40.
I say 35, 40.
Probably is going to give us the most amount of profit. So if you look at the last question, the profit on each lion is $20 and the profit on each giraffe is $18. How many of each animal should the company use to make a maximum profit? Can anybody give me the profit equation? Ethan?
Would it be 35 times 18? Wait.
I just want an equation first.
Oh,
Yes.
18 or 20x
Here we go.
plus 18y equals
Okay, so
Maximum
20x
profit.
plus 18y is equal to the maximum profit. And then if we have, Ethan I think was plugging in numbers, 35 lions and 40 giraffes, what would that maximum profit be? Because we know that if we have 0 lions and 5 giraffes, there's no way we're going to get a maximum profit with that.
I got it.
How much are we making, Nina?
$1,420.
So the profit would be $1,420. We would want to make 35 lions and 40 giraffes to satisfy the conditions of the problem. Questions?
Can I just watch you draw the hand sign also? Because I never knew how to do that, and I'm jealous of people that know how to do it.
Yeah, I've been trying to do it.
Down. Around. Okay.
Okay. It's like a TV, you just don't pick up your pencil.
Okay, that's hard for real. Alright, thanks.
You good?
Yes.
You draw it? You good?
Art class with symbols, apparently.
Yeah, I'm bad with some.
Yeah.
I know how to make the plus signs.
All right, if you could flip your page, we'll have to think of another symbol to try and.
Yeah, there's definitely another one that I can never really.
Cooper, this one's about you, a Potter.
So, the top of the next page, a potter wants to make bowls and plates, and I feel like it should have a different name than a potter. Okay, I feel like it should.
That's Cooper though, look at him, look, he made a Potter.
Oh, you even have it. He does.
Cooper, you're a genius.
Nice looking coffee mug there.
Almost as nice as my pop thing that you throw on the ground.
So try and come up with your own system of inequalities to represent the information in the problem, but I really feel like it should be something different than a potter. Like, I feel like it should have a better name than that, a potter.
Magic plate.
You're a freak.
Alright, so try and answer the letter A.
Okay.
Come up with the equation for the set of inequalities. I am passing back to the worksheet that I collected on Monday, which was like the little review from 3.1 and 3.2. We started in class Friday. I graded it for accuracy, so I did go through, I checked all the problems, I redrew your graphs if they were drawn wrong, I'll show you what the solution should look like, or I fixed any errors that you had in your solutions for the elimination substitution problems. Thank you. So again, keep that worksheet somewhere a safe place.
Okay, I'm stuck on my.
What should I count by on my graph?
This one you can go by ones.
Wow, Ethan, you're really fast. He's a whiz.
Oh, no.
This one's good.
Is that one off?
This one here, right here. That's
Oh, no. Oh, it's like number of poles you need 1 and 4. Wait.
so it is just bowls.
Oh, just poles. I didn't even realize that. I was thinking both were poles.
Okay, I think. So how many inequalities should I have?
3.
I have 3. I need one more. 3.
You're gonna need y greater than or equal to.
I need 11.
What?
0. Why 0?
Y is greater. Yeah.
They can make it also. Wait, is that screen? I have 3 greater than equal
I'm mixing up my parents. Wait, so
All right. So the first problem, or the first inequality, deals with the pounds of clay. you have at most 40 pounds of clay. You can't use any more than that. How many pounds does a bowl use? How many pounds does a plate use? Well, it says a bowl uses 5 pounds and a plate uses 4 pounds. So both of those pieces of information need to be used in that inequality to kind of show that I'm using 5 pounds for every bowl that's made, 4 pounds for every plate. I can't exceed the 40 pounds of clay that I have. I mean, we don't have more than 40 pounds, so once we use it all, we can't make anything else. The second one, let's see, the potter wants to make at least 4 bowls. How do we write that? Okay.
X is greater than or equal to 4.
Right, x is greater than or equal to 4. It's not x plus y because it's just the bowls that we're talking about here. So we need to at least make 4 bowls. Doesn't say anything about the number of plates. So if I need to at least make 4 bowls, we still have to say something about the plates. We could make 0 plates. We don't have to make plates in this case. It doesn't give us any condition comparing the two together. But I can't make a negative number of plates. So y must be greater than or equal to 0, x is greater than or equal to 4, and then that first inequality, 5x plus 4y is less than or equal to 40. Chelsea, can you give me this first inequality and y?
Y is less than or equal to negative 5/4 x plus 0.
So because it's just plus 10, there are 20 lines on that graph. You don't have to count by 2s, because that would really shrink the graph. So just count by 1s.
Could you just find the what's called intercepts too?
You just find the intercepts too.
Like could you also do that? Like 40 divided by 4 is 10.
Oh, yes.
Yeah,
Yes. So if you would rather graph that using the x and the y intercepts, sure. Again, make sure you give me some kind of label so that I know how you're counting, even if you're counting by 1s. X is the number of bowls. Y is the number of plates. And then our first inequality says, I'll graph the x is greater than or equal to 4. So that's this here. And then y has to be greater than or equal to 0.
My graph is looking
And then it's, as Chelsea said, negative 5/4 x plus 10.
My graph is so cute.
So up to 10 on the y-axis. Make sure you're going over to the y-axis. Don't use the x line that you made. You're going down 5. Over 4, it should work out nicely. And you get a triangle this time.
Wait, what? You didn't get a triangle.
Oh.
I just stated the wrong part. Again.
Yeah, because that would be greater than this. So after you have your graph drawn, list the 3 vertices.
Pull my verse. Okay. Bulls.
Does anyone have the 3 vertices? What do you have, Dylan?
4, 4, 5, 8,
And 8, comma 0. Good.
I saw names.
So the last question then for part C, the profit on a bowl is 35 bucks, and on a plate is 30. And it says we want the maximum profit. So we've got to decide 4-5 versus 8-0. Which one gives us the maximum profit? Obviously
Probably
the
4, 5, I think.
do you think the 4-5?
That's how I think it's prediction.
Yeah.
So let's plug them both in. 4-5, 8-0. 4-0 isn't going to be a candidate. This 4 is less than 8.
And if the 0 is less than 5.
And remember, you're just plugging in a 4. Sorry, I missed a y. And the 5. So you're just plugging x and y into the equation.
Yeah, it's definitely going to be 4, 5. Come on. Actually, maybe not. Actually, maybe not.
It was a close call.
I All right, so what,
It was.
Nina,
close.
do you
Wow.
have?
Yes, I did.
Yeah.
Okay, so what do you have for
Yes.
4 and 5?
290.
290.
Oh, please let me be right.
And then 80 is
280.
280. Very close.
That's 80.
So the maximum profit would be $290 if we made 4 bowls and 5 plates. It is an expensive
Alright,
bowl.
here's the divine amendment. I gotta make this and sign.
Please make sure that you are checking because those values were close. It could have easily gone the other way. So make sure that you're checking those to see which one is the maximum value.
Oh, it's a sheet of paper.
Okay, so this is a
Actually,
it is in the book. So there are 2 problems in the book. I have the book open if you want to take a picture of it. This sheet is for you to kind of fill out. And it also has graph paper on it for you. Either way, you need graph paper. So these are kind of like guidelines as to what to follow when you're creating these problems. So all your work can go on this page. You don't need another page for homework, but you do need the book problems.
We're tired. You're gonna out here. I gotta take a picture.
So feel free to come up, take a picture of the 2 problems on page